Today we're going to talk about GoldSim's implementation of the WGEN model, which is able to simulate some climate information such as precipitation, daily high and low temperature, and also solar radiation. First, what I'll do is talk about an application in which this model can be used and how to implement it, and then I'll go through and talk about some of the details of how it's built. All right. If at any time during this presentation, if you have questions, please do let me know by typing the question in the chat, and then I will either answer it during or after the presentation. All right, so let's get started. By the way, those of you that are just joining, you should be looking at a GoldSim model currently. If you don't see it, if you ever have problems hearing me during the presentation, please let me know. Okay, I'm going to start with a short poll here, and just to see what your experience is with this model. All right, great, thank you. It looks a little bit different from the previous session on Tuesday. It looks like a few of you have never heard of it. Some of you have heard of it, never used it. Only a handful have used it before. Okay, thank you. Next one is similar. Okay, so we've got a couple of no answers here that you do not plan to use this model, but hopefully this presentation will be at least useful in just seeing the capabilities of GoldSim, even if you don't plan to use it, which is fine, because you will get to see quite a bit of GoldSim's capabilities in general by watching this. But good to see that a lot of you do plan to use it in the future, because it is quite useful. All right, thank you very much. Okay, I think I need to now start sharing the screen again. Oh, no, you should see my screen. So if you don't see my screen, let me know. But looks like we're back in business here. Okay, so what I want to do right now is show an application. What we're looking at right now is the model as it will be if you download it from our library, and it's intended to be used in a general sense in which you can apply it to any location on the planet. That's the idea. It also allows you to specify whether you want to be working in metric or imperial units. The model was originally built by some folks at the National Weather Service for locations in the United States, and so it was all kind of geared toward using English units. But since we want to apply it to anywhere in the world, most people are using metric. I've had to make some changes to it so that it can work regardless of the units that you decide on, which I'll talk about here in a bit. And that would probably be the majority of the changes that I've made to the model since it was translated from Fortran code. But it looks like we have somebody just asked, how can I open this model? I'll talk about that at the end. It's in our library, and I can show you how to access it. Yes, good question. Thank you. Okay, so this is the model, and what I want to do is just show how I can take this and implement it into my own application. So let's say, for example, that I want to I want to use this model, which, by the way, this model is generating outputs of precipitation, min and max temperature, so daily highs and low temperature, and then also solar radiation. So let me just show you some of the results that I'm talking about here. If I go to the dashboard, now this is just kind of a sample showing some of the results in various ways, but it's really not, it's really just here for a temporary display, something that you might not even implement in your model. It's just here to show you the main basic results that we have. And these are showing percentile time history charts because we have run this model for 100 realizations over a 1-year period, and that 1 year could be any year that you choose. It could also be run for multiple years. That is all. Um, it doesn't affect the way that the model is running. So if I double click on one of these charts, let's say the daily precipitation rate, then what you see is a percentile chart, but I can change that to look at a single realization or a single scenario. And you can see that we have many different possibilities there. We can also look at maximum temperature. So this is all being generated stochastically within the model based on just a few parameters. There are no time series that are driving this model. It is just using some basic parameters to generate these outputs. We can also go to a verification page that shows how the model generated outputs generally compared to observed records. So for example, monthly total precip values that are generated in GoldSim compared to the observed records. That's this first chart right here. So this is just a good way to make sure that the model is producing values that are similar to what was observed. We've got precip totals, how many days greater than 2 inches of rainfall, how many wet days, how many consecutive wet days in a row. Over here, we've got high and low temperature averages. We have the peak high for each month, the minimum low value for each month of temperature, and then over here, how many days greater than 95 degrees Fahrenheit, how many days less than 32, average solar radiation. So this is just a good way to say, okay, is our model producing values that match of the observed record? And it looks like it's working well here for this location. The model, when you download it from our website, it will be set for a specific location, and it happens to be Columbia, Missouri. And the observed values are also for that location, and turns out that it's also for the years 2011 through 2022. That's just the data that happens to be in the model when you download it. Okay, so what I want to do now is say, let's build a model that calculates evaporation, that relies on the information that's coming from this model. Okay, so to do that, let me just show you how you would implement that. Okay. So let's say we want to just take what we have here and put it into a new model. So I will go over to File, Save As, and then I'll just save it as a new model, and I'll call this Calc Evap for Columbia, Missouri. I already have a model here called Evaporation Columbia because I was testing this process, but we'll call it this. And then what I can do is create a new container and say climate generator, something like that. And then I'll take everything in this model except for that container and move it into here. So now what we have is a new model, in which I have moved everything into this container called climate generator. So that's one of the nice things about GoldSim is you can just easily drag and drop elements and move them into a container to reorganize the model. But so the model that we were looking at, if I go in here, you'll see it's all in there. What this model originally did was read information from Excel. What you can do if you don't want it to, if you want to unlink it from Excel, then you can take the values that were exported to Excel that are coming from there, and you can just load them into data elements instead of using Excel. So that means all I need to do is just delete this element and change the name of this container so that it has the same name. And then the model will then read the elements locally instead of reading them from Excel. And so then another thing I can do is say, let's run this for some future period. And then we can run the model, let's just say for now, for one realization. And I realize I'm doing a whole bunch of things here. I'll walk through how this model works and everything in a bit. I just want to show an application. This model is now running for, oh, wait, it should not be running for multiple realizations. Let me start over. I guess I didn't check the box. Okay, so now we're running for a future scenario for one realization. So this is running for in the future, generating one realization of precipitation, temperature, and solar radiation into the future. And it's just generating it from that model. Now what we can do is we can say, let's go and let's look at evaporation. So there's an evaporation model we have in our library that you can use. So I'm just going to select everything in here and copy it. Go over to this application model here, create a container called evaporation. And then I'll paste that in here. All right. Okay, so this model calculates evaporation using high and low temperature and solar radiation as inputs. It's an empirical equation that is unitless, but it does require that the temperature is in units of Celsius and radiation is in terms of megajoules per cubic or per square meter. So all we need to do is access that information from our climate generator and take those units off. So what we can do then is just replace these time series with an expression element that's in the same units with the units stripped off. So then we can just refer to this climate, the WGEN model outputs, temperature max, and then I'm just going to strip off the units in terms of Celsius because that's what this equation requires. And let's see, did I say T max? Okay, let me change that to T max. And then T min. Let me see here. T min, temp min. And then strip off the units in terms of Celsius. And then one more, radiation. and then strip off the units in terms of megajoules per square meter. Okay, so this equation can now accept those three inputs. And now we can run the model to calculate evaporation, which is generated stochastically. So here's our evapotranspiration that we've calculated using high and low temperatures and solar radiation generated stochastically. So we did not use any historic time series as direct inputs to this model. We only used parameters of the WGEN model, which are essentially this table of information here. These are the main inputs. And then we have we have a few temperature and solar radiation inputs. So just this table of data here, and then also this table of precipitation parameters is driving everything that we need to calculate stochastic evapotranspiration values over any period of time that we choose on a daily basis. So you could use this to drive a model to look at, let's say, a reservoir that has water evaporation that you want to look at, or maybe an agricultural model in which you want to calculate crop demands, any kind of model that might require any of the three precipitation, temperature, solar radiation outputs. And if you want to drive it for any period of time in the future, you can do that with this model. So somebody just asked, will this be available as a recording? And the answer is yes, I am recording this, and I will, like I do with all of our webinars, post the recording on our website so that you can watch this later. Okay, so now that you've seen kind of what you can do with this model, let me talk about how the model works. Okay, so I'll close that and then now open the WGEN model. All right, so I realize that I probably just ran through a bunch of stuff that might get your head spinning a little bit here, but let's just back up a little bit and talk about this model. So the WGEN model is, like I mentioned earlier, was originally created by some people at National Weather Service. Actually, I think it was also part of the NRCS, or what was the Agricultural Research Service back in the 80s. It was developed in Fortran. The source code can be downloaded online, and it's also in this container. It's called Fortran code, and you can just copy and paste the text if you want. But there it is. That's where all the equations come from in GoldSim. And like I said, I've made a few changes to it. The main one being that we have, specifically, we have units that are going to allow you to run this in either metric or English units. But also, as we've had more and more people use this in different locations, we've been finding one thing, for example, it was being run in some areas that were very cold up in northern Canada, and with a lot of negative temperatures, if they're working with Fahrenheit or Celsius, we decided to have this model run everything in terms of Kelvin, so that we're not dealing with a lot of negative values. We were having some problems with that. And so I just changed it so that everything is in terms of Kelvin, and so that that's no longer a problem. The other thing I did is we found that people using it in Australia Being in the southern hemisphere, we're working with a negative latitude, which also for some reason has caused a bit of a problem. So we revised the model to make sure that it works for any site latitude that you provide. And then we also did some verification by comparing the model results to observed records in many different locations, cities throughout the world. And so in my folders here, I have test runs for Missouri, LA, California, Minneapolis, Minnesota, Salt Lake City, Utah, Seattle, and Victoria, Australia. So we ran it through all those locations and found that the results do match well to observed records. So I had to go through and do that, but the model that you download from our website will have verification comparison values of observed records for, like I said, Columbia, Missouri, but you could do the same for any other location of your choosing, as long as you make sure that you populate the model with the observed records for your location so that you can do that. But let's see, looks like we've got a question. No, okay, so let's talk about the model itself and the file structure and everything. There are 4 files that you will need to set up a run. The first one you need is this one called WGEN PAR, which can also be downloaded from, well, all these files can be downloaded from our library. But this is the first model that you'll need to run. In order to run it, you will need to populate it with some time series records of observed precipitation, temperature, and solar radiation. And you might say, well, I don't care about solar radiation. I just want to do temperature, or I just want to do temperature and precipitation, or whatever is you're choosing. You don't have to have all of those. You don't have to have all 4 of those. Sometimes it's very difficult to find daily measured solar radiation for your location, and that's okay. You can just keep the values that are already in there, or just make up values and put them in there as dummy variables and just not even use it. So you don't have to have it if you don't have it. If all you care about is precipitation, then you can just populate it with that and ignore the others. However, if you are choosing to simulate temperatures, you do need to populate it with precipitation, because the temperature results is a function of whether it's a wet or a dry day. So it does take that into consideration as it's simulating temperatures, high and low temperatures. So if you want to build a model that uses, or that simulates temperature, daily temperature, then you will need precip and temperature inputs. Okay, so let's go ahead and open this model and see what it looks like. So when you first open this model, the WGEN PAR model, this is just a model that generates parameters that WGEN relies on to calculate the values that I was showing you. And so all you have to do is just walk through these steps when you download this model. And the first one is to choose whether or not you want to be working in imperial or metric units. If you choose metric, then it will tell you your time series information that you feed this model must be in these terms. And that's just the way it has to be. So if you go online and you get your data and you say, well, I found information in millimeters Celsius, but my solar radiation was in something else, well, you'll have to make sure you convert that before you load it into here. And the way that it gets loaded is through Excel. So there's an Excel file that comes with this model, and that is called WGEN PAR XLSX, and it must have that name. That's what this model is looking for. So then when you click on Input Excel file, it will open this file, and it must be located in the same directory as WGEN PAR. As long as you have that file located in this same directory, then you can run this model. So once you choose the type of unit you want to work in, then you open the Excel file. Here's the Excel file. And then you just need to, let me move this to one side and then move this to the other side. Okay, so this is what the file looks like. You must paste the data starting in row 6 and down. And then put in, just for your reference, the units. These are not going to affect the model in any way, but it is just for reference to make sure that you're working in the right units. Make sure to type in the units that you are working with. So you might gather this information from some online source, then just go ahead and replace what is here. So you could just scroll down and then just delete this information. And then paste in your values. It is recommended, and I realize that this test case is only including 11 years of data, but it is recommended that you find at least 20 years of daily observed records in time series for this model to generate good parameters for WGEN. And you might be wondering, well, if I have time series records, why don't I just use those? Why am I using WGEN to generate stochastically derived information? Well, that's a good question. Also, that was asked in the previous session. The reason for it is because with only 20 years of records, you are essentially just saying that's what will happen going forward in the future, and there will be no variation from those 20 years. That is what it is. The nice thing about stochastically deriving this information is that we can use randomness to generate any combination of things that is based on this historic record, and it will, on average, generate monthly values that are similar to what has historically happened, but on a daily basis and continuing forward, you can derive scenarios that we have not experienced before. And also, it gives you the ability to modify the averages going forward. So for example, if you wanted to implement climate changes as we go forward in the future, let's say a general shift in temperature, you can much more easily do that with WGEN. If you wanted to simulate droughts, long-term droughts, for example, it is much easier to implement that with WGEN by modifying the basic input parameters to simulate droughts. And that is something I'll be talking about in a future webinar, is implementing long-term droughts using WGEN. And also I'll be presenting a paper on that at the AWRA conference in November in Seattle, if you're interested. And I'm working with a guy at University of Alabama who studies long-term droughts using paleo records of tree ring data, going back from the year around 1200 to current, to look at these long-term droughts and implement them in this model. So there are many uses of WGEN and being able to generate stochastically driven climate data, but it's important to found it or base it on whatever we have observed in the past, and that's why we're using these time series records here. So anyway, the process is that you paste that information in here. Make sure that you're working in the correct units. If you choose imperial, then you must have precip in inches. Temperature must be in Fahrenheit. Solar radiation must be in Langley. This says LANG. That's just because that's the abbreviation that we use in GoldSim for Langley units. If you choose metric, then you must put these in millimeters Celsius and millijoules per square meter. Okay, so once you have that in there, it's also a good idea just to type in here at the top, what is the location we're working in. Also, it's a good idea just for documentation to say put in the latitude, just so you have it. but this doesn't affect the model. It's just good to have that for documentation purposes. Okay, so this model or this file will then be read in to the GoldSim model when we run it. And then so we can go ahead and close that. Okay, so now this model is going to bring that in, and then you need to specify the date range of your data that you want to look at. And this will then, this by the way, is a new feature of GoldSim 14. These inputs are linked to the simulation settings. So it's the same thing as going into the simulation settings and updating the values here. Okay, so this just happens to be the date range of our time series. It is important to note, if you click this, it's recommended that you start and end in January 1, but you don't have to. Also, it is important, well, it's required that the start date is on or after the very first date of your time series, and that the end date is at or before the final date of your time series. Otherwise, you'll get an error when you try to run the model. Then you put in your latitude of the site here, and then run the model. So then right now what it's doing is it's reading in the time series records, and now it's running. And what it does when it runs is, oh, whoops, hold on. I had the model, I had the GoldSim or the Excel file open, so let me start this over again. I'm not sure what's going on there. Let me see if I need to resave this file. That one's okay. Let's see. One thing that is potentially problematic is OneDrive. We have all these files synced on OneDrive, and because of the way that OneDrive works, it sometimes interferes because it's sometimes the files don't stay on locally, and so when you're reading Excel files, that can cause problems. Sometimes it's a good idea to, if you use OneDrive, is to make them so they're permanently available on your computer. But another way to get around this is to just save them locally. Yeah, it's not always the best idea to have these files on a cloud service when you're trying to read files from the model itself. So I'll just save them to my desktop and try this again. Okay, let's try this again. So I just copied over those 4 files and put them all. These are all of the files that are needed to run the model. Okay, that looks like that did it. All right, so when you run the model, then you'll see that you can view the output file of this model, which is 2 sheets here. Let me open this. So the main part is the WGEN inputs. So you don't need to touch these. These are what are used for WGEN to run. It uses the same latitude value that you entered, also the choice of your display unit. And then these are the main inputs for driving precipitation. And then for temperature and radiation, these are the values for that. One thing to note here is that the Fortran code, it does everything in terms of Fahrenheit, inches, and Langley. But like I mentioned earlier, I made some changes so that everything is in metric. And one really important thing is the temperatures in Kelvin. But so these outputs will look a little bit different than what you might see in the Fortran documentation there. But if you converted everything, then you would see similar results there. Okay, so this is the information used to run WGEN. And then the next tab is observed stats. So that model also will roll up these numbers that it gets from the time series and calculate things like what's the average total precipitation each month. That's what it puts here. And this is all just taken from the time series that you put in. And these are also used in WGEN just to validate your model, which is useful. And it looks at other things besides that, like how many days did you have more than 2 inches of rain? What's the run of wet days? These are kind of important things just to make sure that, okay, it's not only is it calculating monthly averages, but it's calculating extremes too correctly. We want to make sure of that. So that's why we look at things like how many days greater than 95 Fahrenheit, stuff like that. So it's just a sampling of statistics that are used to validate the model. And these are all loaded into WGEN when we run it. Okay, so I'll close Excel. Now that we have generated the file, we don't need this model anymore. So we can just go ahead and close it. Okay, so going back to here, we ran WGEN par. We generated the inputs, which are here in this file, in this Excel file that I just showed you. Now we can run WGEN. And the way the WGEN works is it says, okay, I need those input parameters to derive precipitation. And those are just these tables of values. Let me open that again. To calculate precipitation, it needs these 4 columns of monthly values. PWW is, and by the way, these codes or these acronyms are taken directly from the Fortran code. We use the same variable names. This is the probability that today will be raining if yesterday was raining. This one is the probability that today will be raining if yesterday was dry. And then alpha is used it's used to derive the mean for a gamma distribution, and beta is used to calculate the standard deviation for the gamma distribution, which drives essentially the variability of daily rainfall. So the first 2 columns tell you whether or not it will be raining. The next 2 columns calculate the magnitude of the rain. And then over here on the temperature side, we don't have monthly parameters actually. These are annual parameters, but the site latitude will determine the variability over the seasons, over the months, of how the temperature and radiation will vary. And then all you do is just put in these mean values. So this first one is the maximum or the high temperature, average high temperature on dry days. This one right here is average high temperature on wet days. This is the amplitude. So how much does it vary from day to day? There's some coefficients here for the wet and dry and maximum. Not wet, dry, sorry, for min and max temperatures. So this is a coefficient for maximum temperature. This is a coefficient for minimum temperature. This is the amplitude, a coefficient for the amplitude. Anyway, all of these are used to derive temperatures over time. And then solar radiation parameters are here. This is mean solar radiation for dry days, mean solar radiation for wet, and amplitude solar radiation. Okay, so those are all of the inputs that drive this model. So those are all brought in from Excel here. And so all you have to do is refer to this name, WGEN_par, and then dot, followed by the specific output that you're interested in. So if we were to look at one of these, let's say PWW, probability of wet, and you see we just refer to the Excel or the spreadsheet element, dot, and then that output. And then that gives us that one column of data. And then that runs in the model. So in the model, to calculate, let's say, precipitation, you go in here, and then we have this container called Precip generator, where we do the calculations. And this is all based on the Fortran code. We just essentially mimic what that does. There are some differences, of course. Fortran is just working in an array of a standard typical year of 366 days. But what we do in GoldSim is we walk through time. GoldSim is a dynamic simulator, which makes it very easy for walking through time. So there are some differences between the code and GoldSim, but essentially it's doing the same thing. Calculations are the same. So it's also using what's called a Markov chain algorithm, which essentially is using the probabilities of whether today is wet or dry, and it depends on the current state or yesterday's state. And we can use what's called a status element here to remember what was previously chosen. So if yesterday was wet, then this element will remember that. And if yesterday was wet, then it will say, okay, then I want to use the probability that's called PWW. That's a probability if yesterday was wet. If yesterday was dry, then this element will remember that value, and then it will look at the probability of yesterday being dry to then determine whether today is dry or wet. And if today is wet, then it goes and it grabs the value from our stochastic element, which is a gamma distribution of the magnitude of rain, to calculate or simulate our rainfall. Temperature and radiation use a Fourier function to calculate the variability from day to day and provide some sort of memory of what the previous days were. There are other ways of doing that in GoldSim. We could use things like a material delay element or other things, but we just wanted to mimic exactly what the Fortran code is doing to calculate those things. So that's why we have that in there. But if you go in here, you'll see there's a script element that is doing a bulk of the work to calculate the factors that are used to generate min and max temperatures. Okay, so I realize I didn't go through all the detail of how those models work, but that would take too long. But anyway, I just want you to understand that GoldSim is only using these small tables of information to derive any time period of daily climate data. We could choose any time period and run it. This has no, the model inputs are not a function of any specific date, which is really nice because that makes it very easy for you to essentially implement this into any kind of model that you wish, as long as you've generated the values that are specific to your site, your location. Okay, so once that is done, once you run this model and you're good with it, then you can just take that Excel file and copy and paste those values in locally into GoldSim if you wish. If you want the model to run faster, then you can just copy and paste those values into this data element. These are just copied and pasted from Excel. And the reason you might want to do that is just for the speed of the run. If I run this model right now, let's just run it for one realization. Okay, so we're running it for, what's the time period now? Let's just say we want to run this for 10 years, a future period. Actually 8 years. We'll run it for 8 years. So when we run this, then what you'll see is that once again, it is reading information from the Excel file, and then it runs for that 8-year period. And that took about 1 second, maybe a little more than 1 second. You're thinking, well, that's not very long. That's true. It's not very long. And so if that's not a problem, just go ahead and just keep that connection to Excel. If you want it to be disconnected from Excel, let's say you're good with the results, you feel like it's well validated against observed records, then you can just go ahead and just delete this thing and then just change the name of this container by removing the underscore, and then go up here to Model, Update Expressions, and you'll see GoldSim just reconnects to the values in here instead of the Excel. And so now when we run it, there's no reading from Excel files, and it's very fast. And so that's what we're looking for, is a nice fast run that is then implemented into your model. So with that, then you could implement it in various ways for any site location. So just to give you an example, let's see if we go back to the applications, one of them that I was showing yesterday. Make sure I get the right one. Let's see, this one. So this model is, this is doing a simulation of climate for a location in Australia. And so here you can see that instead of temperatures increasing in the summertime, they are going down in the summer there, and that's because of the site latitude being negative there. So that's why it was important that we tested this model for various locations. So hopefully we've worked out all of the issues for any location. But if you do plan to use this for a project, please do let me know if you run into any issues. But I feel pretty confident at this point that it should be working for most any location. All right, yeah, and then you can click on the model verification and see how the values compare to observed records. Okay, so let's see. Somebody's asking a question. The current library on GoldSim webinar has an older version of WGEN. Could you share the latest version? Yes, that's right. So just in preparation for this presentation, I did make updates to it, and I plan to post the recording of this presentation by next Monday, along with the new version. So you should see it on Monday. Next question. Could you remind us the name of the conference you mentioned about the long-term drought in this webinar? Yeah, so it's AWRA, American Water Resources Association, and it's their national conference, and it will be held in Seattle in November. So if you just Google AWRA Seattle, then you should see it. All right, so that concludes the presentation, and I'll wait around to see if there are any other questions. Somebody asked, you mentioned solar radiation is an optional parameter. Yeah, temperature as well. Temperature and solar radiation, they're both optional. And what I mean by that is you could generate, if you were only interested in precipitation, daily precipitation, you could use this model for only that if you want to. Precipitation in this model is not a function of temperature or solar radiation. So all that means is you could, in theory, in this model, you could come over here and see how these containers, how the arrows are pointing. You could just delete all of this portion of this model and only generate precipitation. Also with solar radiation, you could just delete solar radiation. You don't need it it is not needed to generate the other parameters. That's what I mean by that. Although in the input file, just because of the way everything is set up, you do need to specify, or you need to paste in values for everything that you see here, for it to work right. I mean, you could modify the model to say, look, I'm not interested in radiation. I'm just going to leave this blank. But then in the GoldSim model, you would need to modify some elements to say, don't look for that column. It could be done. It would be quite easy to do it, but it would be a little bit of work to go through and make those changes. But yeah, you don't need the values if you're not planning on generating those outputs. But I would say, just to make it easy to start off, just put values in there, maybe not zeros, but maybe like values that are somewhat close to what you see right here. Just put 200 all the way down or something, and it would be fine to do that. I hope that answers your question there. Somebody, let's see. So we could just put dummy solar. Yeah, that's right. Yeah, you could just put dummy values. Just don't put blanks. That's the important thing, is don't just leave it blank. You have to put something there. And let me show you what I mean by that. If you go into, first of all, the WGEN parameter generator, so this model, the thing is this, the input time series right here, solar radiation, it's in the model, right? It's going to look for that column in Excel. So if you just had blank values, it would give you an error and say, hey, I don't have any values here. Well, you could just delete this. You could just delete these elements. The problem is these impact a whole bunch of other things in the model. So you would have to go chase those around and delete those too, which is fine. You can do it. So like where we're calculating the observed records statistics, you'd have to go into the submodel, into the interface, and you'd have to remove radiation from here, right? And then you'd have to go into the submodel, and you'd have to remove this, and then you'd have to go and remove this container. I hope this is making sense. You just have to walk through the model and remove the parts that you're not going to use, and that would be totally fine. Everything would work, but you just have to make sure that you go through the whole model and remove the parts that you're not going to be using anymore. And precipitation temperature would still work just fine without it, if that makes sense. Same thing with the WGEN model here. We would have to go delete this container, and also on the input side right here, this Excel spreadsheet element, it is looking for radiation parameters right here. So you need to remove these because it's going to go into the file and look for those values. I would say the easiest thing to do is put dummy variables in there for now. In the future, if you want the model to be lean and mean and only working with precip information, then yeah, you could walk through the model and remove those parts. Yep. So yeah, it's not a difficult task. It'd be a little time consuming, but not difficult. So yeah, good question. Any other questions? Somebody said the left side menu looks red, blue, and black. What is the meaning of each of those? Yeah, good question. That's because I'm using versioning in GoldSim. So if you go up here to model versioning, you'll see I have quite a few updates that I've been keeping track of, and it goes on and on. There's a lot. I've been making a lot of updates to this model over time. And every time I make an update, I post a comment in our article, by the way, to just make sure that if you're following our article, that you'll be notified of changes. But in GoldSim terms, if you make any changes to this model, it will highlight in red a change. If there's a change inside of a container, it will show up blue. And then you go into the container and it will show any red items that have been modified. So for example, if I add a new element here, like let's say a data element, you'll see that it will show up over here in red. And then if you print out a version report, it will, let's see, generate a report. It will show you the changes, kind of cryptic changes there, but it shows you a list of all the things that were changed in that version. So then what you could do is when I'm done making any changes, then I could say something like, you know, increment version for publication or something like that. And then once I do that, check the box and close, then you'll see all the colors go away, because now we've moved on to a new version. Now any changes going forward will now be highlighted, if that makes sense. Let's talk about the article. So on our website, if you go to goldsim.com, customer care, go to learning resources, and then you'll see these subtabs here. Go to model library, scroll down to applications. This is all in the recording, by the way, so you can watch this again if you get lost. Go to the hydrology section, and then these are all of our hydrology related models. Go forward one, and here they are: WGEN parameter generator, WGEN simulator. And what I recommend that you do if you're interested in these models is that you click the follow button, and that way any updates that I make, which I always comment for version updates, so you can see all these comments down here. When I make a new version, I'll comment here, and then you'll be notified. You'll get an email that says, oh, there was an update to this model. So it's a really good idea to do that. In order to follow, you'll have to register your name here and then sign in. But that's a good way to kind of keep up to date with new versions of this model. All right. Any other questions? It looks like we don't have any other questions, so I'll go ahead and end the meeting. But if you have any follow-up questions, please feel free to let us know. You can contact us through support on our website, and we'd love to hear from you. Thanks for joining. I hope this was useful, and hope to see you next month.